Amazing. And with that, I think Brendan is here and connected. Brendan, can we get a quick mic check?
Yeah, I've managed to come in. Thank you guys.
All right, absolutely.
Good morning.
Rise and shine. Good morning, GM, GM.
Yeah, I
Cool.
realize I try and keep off of Twitter by deleting it from my phone, the app, and then it never works on my Mac. So here I am, a little bit late. Apologies.
All good, all good. But I think with that, we're just about ready to rock. So, Calanthia, do you want to take it away and kick us off on this episode of the Masa Drop inside the Masa Bittensor Subnet?
Yeah, happy to. Again, hello everyone, and thank you so much for tuning in on your lovely Friday. Hopefully, it's sunny outside wherever you are. So today, Brad and I will be doing a more conventional Twitter Spaces, whereby we are going to deep diving into Masa Bittensor Subnet. As you might recall, 2 weeks ago, well, around 2.5 weeks ago at this point, Masa announced that we are entering into the Bittensor ecosystem. This is such exciting news because the entire team at Masa has been preparing for this moment for a couple months, and we couldn't wait to unveil our Bittensor subnet to you. Today, during the spaces, we're answering some of the most popular questions you have in mind when it comes to Bittensor, Masa's involvement in Bittensor, how you can participate, and the very exciting incentivized testnet we're currently running in partnership with CoinList. So that's the overview of today's spaces. Brennan, do you want to say hi before we dive into the nitty gritties?
Yeah, good to see everyone. Thanks for joining and tuning in. And I'm glad we've had sort of a series of partner spaces, and it's really nice to kind of dive into like a specific topic here. Yeah, I'm personally very, very excited about what BitTensor is doing. There's been some really big developments over the last, couple of weeks. Not just Grayscale bringing their AI ETP into the market with BitTensor, but also just really, really interesting, vibrant, and very impactful subnets launching across the BitTensor ecosystem, of which we will be one of those core contributors. So, for me, BitTensor is the next, Ethereum for AI, Bitcoin for AI, whichever way you want to look at it, being fair launched, being open to everyone. And yeah, just really excited to do a deep dive here with Calanthia and get a little bit more into why we're excited, why you should be excited, and deep dive into exactly what we're building.
Amazing. Great. So I guess the first question is quite simple, which is why BitTensor for Masa? I know in the audience today, we probably have a mix of Masa community members and new joiners from the BitTensor ecosystem. For those who are unfamiliar with BitTensor, Brendan, would you mind diving into why you think BitTensor is going to be the Ethereum ecosystem for decentralized AI? Why did Masa decide to dedicate our engineering resources on building a BitTensor subnet?
Yeah, great question. So I like to start with framing this as sort of our evolutionary journey from where we started with Bitcoin 2009, 10 to where we got to with Ethereum around 2016 to where we are today, which is still, 2 to 2.5 years, maybe 3 years since BitTensor kind of first came into the world. And with Bitcoin, we devised a system that everyone knows and loves, a way of exchanging value without any intermediary. Trustless money. With Ethereum, we took the step to build compute onto that financial layer. So how could we start to program money and execute the program or the logic behind money or value again in a trustless way? So using EVM, and from EVM, every other execution based chain, Solana, um, uh, and many, many others, Cosmos, so on and so forth. All of these chains, bearer chain, that are either using EVM or a similar virtual machine environment to execute code in a trustless way. And what that means is that things like DEXs can be built, ways of creating synthetic sort of derivatives, real world assets can be minted, tokens, meme coins, so on and so forth. We have this huge burgeoning ecosystem, which is now trillions of dollars in value. If we look at Bitcoin being 1.5, 1.6 trillion, this entire ecosystem, just based on Bitcoin and Ethereum alone, are going to grow into a multi-trillion-dollar industry, like $5, $6, $7 trillion over the next 5 years. Now, in the world of AI, with OpenAI, Anthropic, Meta, and Google all building AI models, we have a very different paradigm. We now have intelligence that is being brought into the world through agents, chatbots, and large language models. And there is an opportunity today to provide a similar distributed, decentralized way of bringing that intelligence into the world. We have these, let's call them two players today. We have the centralized, closed source, closed weight models. Excuse me, let me just stop that from ringing. Apologies. Centralized, closed source, closed weight players, OpenAI, Anthropic, Google. We then have open source AI platforms. This is Meta. And what Meta is doing is they're putting out Llama 3, and more recently this week, Llama 3.1, as a platform for people to build on. Now, when we think about the proliferation of these two technologies and the way they're being brought to market, decentralization really is the only way to align incentives around AI. And what Tensor does, Bittensor brings the same alignment of incentives that were programmed for Bitcoin, as in I can transfer money without an intermediary and no one's going to fraudulently take my money during that transaction due to Bitcoin mining. With Ethereum, I can execute some code. I know code has been executed in a trustless way, and I can verify and validate that the instruction I send to the network results in a response. Now with Bittensor, we're using similar game theoretical and economic models to both incentivize the development of AI and parts of the AI stack, as well as bring alignment to AI in terms of how models behave, what prompting looks like, are models safe, are models benchmarked, and building an ecosystem around Tau that closely aligns the support and proliferation of fair, open, and trustless AI is where I'm so excited about Bittensor. You know, Tau is the asset of choice in the same way that ETH and the same way that Bitcoin was on the prior two networks. Now it's Tau. And alongside that, Masa being this critical building block of bringing data. Data is the most fundamental building block for all machine learning and all AI applications. Without data, there is no machine learning models. Without data, there is no AI. So us bringing an aligned data economy using Masa as the incentive token into the Bittensor ecosystem does two things. It allows for you as workers and participants on the Masa protocol to provide data to the network. It also then provides value for the Masa subnet that is providing rich data across the entire Bittensor system for fine-tuning of models, for annotating and labeling conversational data, for RAG, which is retrieval augmented generation. A long, complicated word of saying we're giving an AI memory using data that allows that AI to recall and remember things that make it more adept, more intelligent, and more self-aware. So using data in these ways across the ecosystem, it's a perfect match between the incentive mechanism we have for aggregating data on Masa, and then the Tau incentive mechanism for, rewarding and incentivizing the most valuable machine learning, the most valuable AI contribution to the Bittensor ecosystem. And I'll pause there. That was quite a long-winded opener.
No, I think it was really good because it gave us a very abstract and conceptual way of thinking about in the context of, let's say, what Bitcoin has done to gold and what Ethereum has done to money, what the Tau or Bittensor ecosystem is doing to AI, making it open, permissionless, trustless. And I'm sure many of you guys have seen the new Llama 3.1 model, which was a big piece of news in the open source AI world. And here at Masa, we truly believe in what we call fair AI, a future of AI that people who participate can get rewarded for your contribution. And we think that BitTensor is basically the vehicle that makes it happen. And Brendan, I think you already dived into what kind of role Masa hopes to play in the BitTensor ecosystem by building a Masa Bittensor subnet. Data is really the name of the game. I think you used a few words, which is really interesting, right? You said it's a new currency for decentralized AI. And you said it's, I think, the blood that keeps the body running. Maybe I'm recalling something wrong here, but the gist of it is that,
I love the analogy.
yeah, thank you. The gist of it is that data is one of the most important things when you think about AI development. Let's dive one layer deeper at a more concrete level. What about data is currently challenging for AI developers, and what can decentralized data network such as Masa do to change that?
Yeah, it's a great question. It's a great question. With with data acquisition, as someone that is doing, let's say, one of three things. Number one, you're building a foundation or a frontier model. A foundation or a frontier model is something like ChatGPT, something like Claude, something like Llama. And Llama 3.1 is a frontier model. Still a foundation model. And a foundation model is typically trained on a general data set. So foundation model is meant to be good at many things. It can answer and provide information on mathematics. It can similarly do the same with language. It can similarly do the same with like lower levels of logic and reasoning. So you get this like general foundation model that is typically generally good at many things. The way you build that model, if you're building a model and training a model in this like step 1 of 3, is you're going to go out and you're going to scrape and acquire a general set of data. Now, what does that look like? It looks like all of Wikipedia's data. It looks like news articles from the web. It looks like conversations that people are having on Reddit, conversations that people are having in chat boards, news boards, so on and so forth. It really is all of the internet's history of human activity online distilled down to create this general foundation model. So without data going in to that foundation model as parameters, the most recent one here with Llama 3.1 is 405 billion parameters, cost roughly 650 million to train. I can't remember how many hundred H100s Meta used, but it was a significant number of H100s. It costs a lot, not just to train that model, but also go out and acquire the structured data. So step 1, if you're wanting to take a foundation model and retrain it or pre-train it, which is really the paradigm we're in, if you're looking to train a foundation model in V1, you've now got to compete with spending probably $1 billion to get the best frontier model. So in this paradigm of like, in step 1, you're going to go out and scrape mass amounts of data, structure it, and then use it to train a foundation model. Step 2 is to like pre-train or fine-tune. So let's say, for example, we want to take this general model and we want to make it really specific at solving a particular coding problem. That coding problem could be writing Solidity or writing Rust smart contracts on Solana. We're going to use Masa to go out and scrape GitHub for every code example, every blog post on Medium that has a tutorial on how to write Solidity, any YouTube videos. We're going to do speech to text diarization using the protocol. And through Masa, as a developer looking to fine tune or distill down the model from like 405 billion parameters, maybe to 8 billion parameters, and a subset of those parameters are very specific around this coding problem, you end up having a distilled model that is particularly good at solving and providing high accuracy, solidity, and Solana Rust code. And the way that's been done is a developer has come to Masa, they've used the web scraper to go out and scrape GitHub data, Medium data, so on and so forth, to give them a highly structured contextual data set that allows that model to be distilled down to be very accurate for that particular use case. So that's bucket 2. And then bucket 3 is RAG, which is retrieval augmented generation, a really annoyingly complex word for just saying, as a human being, if you give me a prompt card or a cheat sheet, like we've all seen Biden diligently staring at his prompter or teleprompter so as he remembers what to say. As funny as that is and as ridiculous that is, the same analogy can be made for an AI agent. An AI agent has a limited amount of memory that it can remember and retain information beyond its like general foundation model. In order for a model that was trained a week ago, like Llama 3.1, Llama 3.1 was trained up till, let's say, last Thursday. So any question you ask it, it will have the current information generally about most topics up until last Thursday. If we want to use or build an aid that can tell us what to wear today based on the weather and based on our history of what we've purchased from an online store and therefore what is in our wardrobe to wear, we need to somehow get that information into the foundation model. So I would ask the agent, what should I wear today based on the weather? And what the agent will do, it will take those keywords, it will do this thing called vectorization, which is essentially matching today with a date in a database and weather with data that's been scraped about the weather. So it will look for data that is from like AccuWeather. So the developer's gone out, scraped data from AccuWeather using the Masa protocol, put that into a database, and there are 2 important things on there. There is a description of the weather today, and there is a date. And when you put the prompt in, it will find that information, that sliver of data in the database based on the date and the word matching. A vector is just a word match, like weather with weather matches to that kind of sentence. And then the date today matches with the data for today. It will pull that data in to the agent, add it into this thing called a system prompt, which is providing the general model with additional data for today. So as the agent can then respond and say, based on the current weather and your past purchases, I suggest you wear a raincoat because today's weather looks like it's got a 70% chance of raining. So this is like the third use case and why like data is so bloody critical in AI. Without the ability to give AI eyes and ears and memory and an awareness of its surroundings in a way that doesn't require constant retraining that now costs billions of dollars, you need to be able to scrape data that's relevant for your particular use case, structure it, and then consume it in your agent, as I just described. So that is why decentralized data, real-time data, being able to get data feeds into AI in an open, transparent, and free way is just so critically important. The blood in the veins of AI, as Calanthia said.
That's amazing. And just to recap, and I love all the details that we got into because I think that gives people a good comprehensive understanding of different types of model, whether that's more foundation model or specialized model, and what kind of data is required for each type of model, and Masa's role, more importantly. Brendan, out of the 3 types you just mentioned, the first one being the more Llama 3.1 foundational model, number 2 being more specialized model, and number 3, you specifically dived into RAG. What kind of role does Masa play into it? how do we support developers in this process?
Yeah. Today, the lowest hanging is in buckets 2 and 3. What I think a lot of people have really got to adjust to in today's AI paradigm is just the insane speed at which everything's moving. If we say we created a team out of this group on Spaces today, and we all said we're going to build a foundation model in bucket 1, we would go out and scrape a massive corpus of data using Masa, which is possible to do. We would then have to invest very heavily, and basically we're competing with every other institution on the amount we're prepared to spend on training that model. And like really now you've got to be thinking about spending billions. So, in terms of where the low hanging fruit is for developers, for the network, for Masa, and where the highest value is, it's really in bucket 2 and 3. It is identifying and finding what is the narrowest set of data to provide the highest value to a user, and specializing very narrowly on the data there to fine tune, distill, or pre-train a model on a specific use case. This still be expensive. Like it can still cost you quite a lot of compute to do this. So, for example, we want our agent to speak more fluently and more naturally. I'm sure, as many of you will have noticed, when you're dealing with like a free AI agent, the way they speak to you will be unmistakably AI. If you start using some of the newer models, and we have a subnet after party that's doing this, that we know and love what they're doing on Bittensor, they are using conversational data. For example, the conversation that Calanthia and I are having here today can be used to improve the way in which AI actually speaks to the user, and you can see that reflected in the most recent models. So fine tuning is extremely low hanging fruit. You can quantize a model, which means shrinking the model down, providing a very specific data set for it to pre-train it using annotated data, and get a small model that runs, for example, on my phone. It could run on my laptop. It could run in like an edge device and provide really accurate answers where a large foundational model can't. And then, of course, there's RAG. And I honestly am in this complete love affair with what RAG can do, because it allows anyone at very low cost, truly anyone, to get data very rapidly into a model to provide extremely accurate outcomes and much improved log knowledge and context. And the biggest opportunity we have right now on Masa, and where we're seeing like a lot of opportunity, is in the RAG kind of infrastructure stack, getting data from sources, getting it transformed and pre-processed, and then actually delivering it into an agent at a very low friction way, so as better agents that are more intelligent can be shipped quickly to users.
I love it. And just to make him even more concrete, right? Let's do an example here. What if I want to build an AI agent that talks and speaks like Donald Trump? Donald Trump obviously has a huge amount of digital footprint everywhere. Some people can take this away as an idea. I know there are a lot of meme coins being traded. Why not an AI agent, right? For the election too. So let's say Donald Trump has a huge amount of digital footprint across different kind of formats, whether it's tweets, YouTube, videos, podcasts, television appearances, but also web article mentions of Donald Trump. As an AI developer who's trying to build a Trump AI agent, before Masa, how would I go about and gather those data needed? And with Masa, how do I achieve that?
Yeah, great question. So there are two pathways. There is a go out and scrape and collect your own data and build everything yourself to get the data. I'll cover how complex and challenging it is. The second is to go out and acquire a data set or find a data set on the public internet, maybe through Kaggle, maybe through Hugging Face, using a publicly available data set. Issue with that is you're going to find that everybody's using it. It may be difficult to differentiate yourself with that data set because 15,000 other people are probably using it. Okay, so that means that we want to really differentiate ourselves. We want to have something that's like very unique, is better than everyone else. that means we need to acquire our own data set. Now, in the prior paradigm, you would need to go out and hire a lot of engineers, build your own scrapers, your own pipelines, run the infrastructure yourself to go out and acquire this data. And that's honestly what OpenAI, Meta, all these other companies have done. They've invested tens of millions of dollars in doing that for their foundation models. Now, that's obviously huge friction. Again, the cost to do that is extremely high. There are only so many developers globally that can do this kind of work. There is not enough developers for every AI application that's being built. Therefore, you need to have infrastructure to do this that you can buy and purchase as like a SaaS product or whatever. So enter platforms like Apify. These are all very expensive platforms where they will run scrapers that you deploy yourself. You still need to be technical to use these. So once again, requires technical expertise and costs a lot of money and can take a lot of time to just begin scraping your first data set. And they can break, they can be problematic. And like I said, they're not cheap. Now enter Masa. Masa is a community of workers, of which many of you on here, plus 40,000 or 48,000 of you before over the last 12 months have run worker nodes on the network. And instead, what you're doing is you're providing compute and infrastructure for code that we've written as a foundation to be able to scrape and structure data in the same way that developers and these other platforms have done, like developers for like the last 7 years to build AI, and more recently the last like 1 to 2 years, the paid services. And actually today, you as workers are getting rewarded with Masa as emissions from the network, the same way that miners and validators on Tau get emissions from the network. And it's free for developers to access this data right now. There is going to be a fee model. So as a worker or a miner, you're going to get both emissions plus fees. And the fee is based on the difficulty of getting the data, the amount of data you provide, and then the latency of you providing data. So the more compute you have, the quicker you're going to respond to the network to give the network data. So if I want Calanthia's last 100 days of tweets, I would use one of our scripts in our awesome Masa to scrape the Masa network, use the network to go out and fetch the last 100 days of Calanthia's tweets. And I could do that trivially in probably 20 minutes, 15 minutes maybe, get all of this data that's otherwise not available for me in a solid data set. And in this case, we're doing Trump's. So I'd go out, I'd scrape Trump's tweets. We would go out and get all of the YouTube videos of where he publicly pull those into our speech to text diarization engine. Go out and find any other dialogue based articles where speech and prose is being reflected in natural language. Once that's been scraped, convert it to this thing called embeddings. So an embedding, a segment of text that relates to a topic. So now we're talking about Trump. I've said Trump 5 times. I'm embedding what I've just said. Trump is going to be the key in that embedding. So if I had a database, I just said, if we want to build a bot using Trump's tweets, we use tweet feed data scraper. That's our embedding, that sentence. If Calanthia goes onto the Trump bot and says, how do I create a Trump tweet bot? The bot will go out, use the vector, which is the occurrence of Trump in Calanthia's question, to match Calanthia's question to the embedding, pull in the embedding into the system prompt, and it will give a response that includes the information that's held in the database. And in the case of making an agent speak like Trump, you're going to want to have a system prompt that says, using data from public speaking and rallies, speak like the text that you're being presented. And then you insert So every time that Calanthia asks the bot a question, behind the scenes, there is a system prompt that's going out and fetching a segment of one of Trump's speeches that's recent or multiple sections, putting that into the prompt without Calanthia doing anything, and telling the agent to use this information to start speaking in the tone, the style, and the context of that embedding. So when the agent speaks back to Calanthia, you'll get a response. And you can practice this. Like, anyone can do this manually. You can go and fire up GPT or Claude. You can grab a bit of text that someone said. You can say, using the text that was presented, give me a response in the tone and voice of the text I presented, and speak to me naturally. I'm Brendan, how are you? And it will give you a response that uses the text that you put into your prompt to reply to you in the voice of that. And that's all RAG is. RAG is doing that all on the back end, using a very similar mechanism that we as human beings use to associate a question with a context. So Calanthia says to me, how do you build AI? I think AI build. I go and fetch the information from my memory that has the keywords AI and build in it. I bring that into my memory, and then I can start talking about the extended information around that, which is using these tools, using data. They're all words that are around the two keywords AI and build that relate to them. And that's all RAG is. So hopefully that's a full detailed explanation of how we give agents memory, how we make them smarter, and how we can give them prompts to speak in certain ways like Donald Trump.
Great. Free idea for everyone. Now everyone can grab some rally speech and train a Trump AI agent. I'm looking forward to seeing the results of that. Switching gear a little bit, because time actually flew by. We already have been speaking on those topics for 35 minutes. I want to get deeper into the Masa Bittensor subnet, and specifically would love to dive into what kind of roles we have on the Masa Bittensor subnet, particularly for those who are unfamiliar with Bittensor and unfamiliar with the structure of having miners, validators, and developers. Brennan, can you walk us through categories of players? What kind of requirements and then what kind of role do they play?
Great question. So the Masa protocol and the Bittensor subnet have really key, we're going to call them actors, players, on each of these networks. On the protocol, we have validators, we have, workers, and then we have oracle nodes, or nodes that are used by developers, or peer nodes. Validators ensure that everybody on the network gets fairly compensated. So they score, they rank, and they weight workers, and oracle nodes for their contribution to the network in the case of workers, and their consumption of the network in the term of developers consuming the network. So we have these three players. Each player has to stake. You have to stake as a validator because you're responsible for governing the rewards on the network. There are institutional validators that are joining Masa Republic and many others who are operating those nodes. Community members can delegate stake to those validators. If you have a large enough stake, you can also become a validator as well through like the proof of stake mechanism that is on the protocol. Worker nodes, you stake to provide work. If you start behaving fraudulently, so for example, if you start providing fake request responses to like a Twitter request that is just false data, validators will identify that in their consensus mechanism. You'll be negatively weighted, negatively scored for your response, and stand a high likelihood of losing your stake or being slashed. So that is a mechanism by which, in very simple terms, workers remain honest. If we look at oracle nodes or peer nodes, where you stake and then pay fees to access data on the network, as a developer, I want to get data from workers, and I want that data to be true, and I want it to be untampered with. Validators are making sure that's untampered with. Validators are also making sure that workers provide responses quickly, in good time, with low latency, so on and so forth, and that all of the record keeping is kept up to date. But on the Oracle node, if I start spamming the network, like if I keep requesting Calanthia's data, 100 times a minute, that's putting a lot of unnecessary load on workers. So two things are going to happen. I'm going to need to pay more for those requests, and I stand a high chance of being rate limited and weighted negatively because of my abuse of the network. So I could be slashed or I will be charged more for each request. Really similar to ETH and Bitcoin. The more transactions that are happening on Bitcoin, the higher the transaction fee. The more transactions, we've all seen ETH fees go to the moon because of NFT minting in the past. That's because there's so much competition for compute. The price goes up proportionally because if it didn't happen that way, people would constantly attack the network. And we see this on other networks that don't have similar anti-Sybil or anti-abuse kind of mechanisms. And then on the subnet itself, we have validators and miners. Validators are typically part of the existing Tau community that join to, again, validators ensure that miners request data from the protocol and then do some work on the data. That work might be, for example, we have a new subnet we're working with. They are going to be obtaining and scraping real estate or property data through the Masa protocol, basically MLS listings in the US, and then using that data to predict the price trends or the price of property in the US using their own incentive model on their subnet. Now, in order to go from the scrape data to data that can be used and consumed by this other subnet, transformation and pre-processing has to happen to that data. The subnet is going to be incentivized to pre-process that data. So that might be annotate or trim or structure or remove certain keywords or use an LLM to extract certain context from it. Like maybe I just want the price of the property, the date it was last sold, so on and so forth. So validators will send requests, miners will request data from the Masa protocol, which provides fully decentralized data scraping, much different to other subnets that all use centralized services today. So this is bringing completely decentralized data scraping to the Bittensor ecosystem through the protocol and incentivizing this additional pre-processing processing layer on the subnet that allows data to be refined and transformed into lower level, either pre-processed or even in certain times synthetic data that can then be used in machine learning models and subnets. So there are actors, 3 actors on the protocol. If you want to delegate, if you have a large enough stake, you can be a validator. Otherwise, participate as a worker. Bring your Twitter login, bring your Discord bot, bring your web scraper functionality, very easy to get up and running. You can be a developer to consume the data, but then also on the Bittensor subnet, you can be a validator if you have a large enough stake again, or if you delegate, and you can be a miner that's processing this data, and you receive Tau emissions and Masa emissions on the subnet as well for being a validator and a miner. So hopefully that explains everything.
Yeah, definitely. Thank you for walking us through not just the Masa Bittensor subnet, but Masa protocol. Definitely see a lot of parallel structure there and interesting ways for developers and participants to join as miners, workers, validators, and users of our network and data. One specific thing that caught the Masa community attention is the fact that the Masa Bittensor subnet has limited amount of miner slots. Specifically, there are 256 of those. This is quite common across the entire Bittensor ecosystem. But for those who are less familiar with Bittensor ecosystem, Brendan, could you please dive into why there's such a limitation? And perhaps more importantly, help us understand the game theoretical design of the Bittensor ecosystem.
Yeah, so every layer of Bittensor sort of relies upon this competing game where every participant is competing for a limited set of rewards. every tempo, which is a period of time. And in a day, there's a certain amount of tau that's emitted. Similarly, when the economic layer on Masa launches in a couple of months, it'll be the same system on Masa as well. There'll be a limited number of missions, and every cycle or epoch or tempo, a set of miners workers will be competing for a limited set of rewards. So what Bittensor has done, they decided to take this a step further, which is not just limit the rewards per tempo, but also create a game within a game. And that game within the game is that in order to keep your slot or your ability to participate on the network, you have to compete with other miners. So you're not only competing for a limited set of rewards, you're also competing within a limited set of slots to access those rewards. So if you, for some reason, start being very slow to respond, you've reduced your amount of compute, so on and so forth, you're going to get weighted lower on the subnet, and you stand the risk of losing your right to earn rewards because you're not providing enough value. So what this game does, it's constantly incentivizing a behavior pattern that is self-improving and competitive in the truest kind of sense of the word, that the person or the people that are most aligned with this particular subnet by delivering value get the right to earn rewards, get the right to participate in that next competition, which is when you're in that 256, you're then competing with those 256 and competing to keep your slot. So it really drives a very, very well-formed game theoretical model that is constantly incentivizing good behavior and good actors on the network.
Yeah, I know we already touched upon this, but it's probably worth repeating in this specific point in time. What does good mean for Masa Bittensor Subnet? For example, if I'm a miner of trying to participate in the Masa incentivized testnet, how can I improve my performance in order to gain one of the much prestigious 256 slots? How do I get in there?
Yeah, good question. Good question. So three kind of key takeaways here. Number one, the speed at which you fulfill the request. So typically, the better your bandwidth, and in a way, the more CPU you have, the faster you can respond to a request, just from a processing and bandwidth perspective. So number one, having good bandwidth, having a good connection to the internet, and having a good amount of compute. Compute isn't really the driver here, but bandwidth is, will allow you to respond more quickly. Number two is responding with true and factual information. We've already seen on the subnet that people are as running malicious miners that submit fake responses. We have a clustering algorithm that deterministically, that is able to weed out and negatively weight bad actors. So someone that's submitting blank fields for Calanthia's tweets is not going to get rewarded for the work they're doing, even if they're doing that work quickly. And then lastly, it's diversity of data. So as a miner, you can serve Twitter data, Discord data, you can provide web scrape data, diarization data, Telegram data. The more of those particular toggles you have turned on the subnet, the more likely it is that you're going to receive a request and you're going to be able to fulfill demand on the network, thereby increasing the amount of data you've provided. And that's the second or the third weight here, is the amount of data you provide to the network is also really, really valuable. So they're the three things you can do. Be available online consistently with low latency. Make sure you're toggling all data sources and all scraper on our protocol and thereby your miner, and not being a bad actor and submitting bad data to the network.
Great. I feel like we already touched upon this, but we'd love to still have a plug about how to participate in the Masa Bittensor incentivized testnet. We announced the launch of Masa Bittensor incentivized testnet in partnership with CoinList a couple of weeks ago, 2.5 weeks ago during ETHCC. And so far, we have seen an overwhelming amount of enthusiasm from participants, from community, trying to learn more about Bittensor, about Masa Bittensor Subnet, and then trying to participate. Brendan, what are some best tips and alpha you're willing to drop today for people who want to participate, aside from the ones you already mentioned?
Yeah. Now, it may feel frustrating that there's only 250 slots. That is actually a Bittensor kind of hard-coded value. It does increase over time. That's where it is at the moment. So yeah, by participating, you'll find that by having more compute, more availability, you will eventually get a slot. But I would say that it's very important to run a Masa protocol worker. While we have the incentivized Bittensor network, we will be following and will have an incentivized network for the protocol, and the best chance of getting rewards, which are distributed between all protocol workers as opposed to a limited set, is to be running alongside your miner while the miner is waiting to join the network and getting a slot. You should be running a protocol worker node, because that is going to allow you to provide work to the network, and you'll be eligible for the phase 3, phase 4 of protocol incentives. So I would say might feel frustrating getting access to the Bittensor subnet testnet at the moment, but that is what it is like in production. That is the real life experience. But there is a massive opportunity to contribute on the protocol worker side while you're waiting or queuing, where you will get incentives, you will get rewards.
Great. You heard it here first. We haven't shared this news with anyone else, that we will soon be announcing an incentivized testnet in parallel to our Masa Bittensor subnet for our Masa protocol. So while you're improving your performance, trying to get one of the prestigious slots in our Bittensor subnet, you can, in parallel, providing work for Masa protocol and still earn rewards when you're waiting and in the queue. We're coming to an end here. Time flew by so quickly. It's almost an hour since we started talking about Masa Bittensor Subnet. I know there are quite a few Bittensor ecosystem builders and OGs in the audience here. First of all, hello, and thank you for joining today, and welcome to the Masa community. We're super excited for you to be here. We'd love to share a little bit more about our technical roadmap in the Bittensor ecosystem. After incentivized testnet, Brendan, what's next for Masa within Bittensor ecosystem?
Yeah, good question. So we'll be going to mainnet on Bittensor in the coming month. I'm going to put it that way. So really excited to both roll out, TAO incentives for miners, TAO incentives for work for validators, and similarly have those participants get Masa rewards on the subnet as well, and that comes hand in hand with many integrations with other subnets. So providing data to partners across the subnet ecosystem, and then from that base, increasingly adding miner functionality. So where I said that the best chance you have is like running Discord, Twitter, web scraper, diarization, all these elements that you can toggle on on your worker node. We'll be adding increasingly more features for like vectorization of data, using LLMs to annotate data and chunk embeddings. So over the next, I would say, 3 to 6 months, you're going to start to see this incredibly rich toolkit for building smart, memory-driven AI as a toolkit that's all powered from this decentralized backend, a combination of decentralized data scraping, combination of decentralized and incentivized data pre-processing with a very powerful, easy-to-use toolkit in Python that will allow you to go from like 0 to hero with an agent in about 5 minutes. this data create very, very smart, very engaged AI agents. That's all going to happen. That latter part is going to be happening over the next couple of weeks. We are moving fast at Masa. Like, if we do not move fast in Web3, Web2 is going to kill us. So we have to be shipping these things really fast. We have to be delivering on the promise. And we can't be building things for 7 years like Ethereum did, because we don't have the luxury of that today. So things are going to move quickly, lots of opportunities to participate, and some great tooling for developers coming out on the back end of this distributed, decentralized like data stack that we're building.
Great. Hopefully through the spaces today, all of you learned a little bit about why Masa is so excited about the Bittensor ecosystem, about the utility that Masa Bittensor Subnet provides, and most importantly, how all of you can participate in our ecosystem, either as a miner, as a validator, or as a developer and user of our decentralized data stack. Brendan, any closing thoughts?
No, just like so grateful for the warm welcome with the Bittensor community. We've got a lot of work to do. And I'm very, very grateful for every node worker, node operator that's with us. We're building a multi-billion-dollar protocol here that is going to have huge value, providing data, this lifeblood of data, the eyes and ears of AI across not only Web3, but also Web2. Web2 needs this tooling. Like today in Web2, to get data for RAG, it's like either you're using very commoditized, undifferentiated or non-differentiated data that's available to anyone, or you're having to build it all yourself. So this is like a fundamental part of the AI stack, not just in Web3, but Web2 as a whole. I'm just very excited to be building with everyone. Can't wait to ship more features. Can't wait to give you more things that you can tangibly and in a tactile way get your hands on to actually test and see how this works. And just thank you all for supporting us. And we're going to continue just focusing on building.
Amazing. Thank you so much, Brendan, for sharing your wonderful thoughts and insights about Masa Bittensor ecosystem and what we have on the roadmap. And thank you, everyone, for tuning in today. Hopefully you enjoy the spaces and have a great weekend, everyone. Thank you for tuning in.
Thanks, everyone.